Alright, this is the video for section 11.3. In this video, we are going to talk about the area of regular polygons. Okay, now keep in mind that the area formula we're going to learn works only for regular polygons. Now, we talked a lot about regular polygons in chapter 7, but I know it's been a little while. That was the beginning of second semester. So just to review, a regular polygon is a polygon with all congruent sides. And it also has all congruent angles. Okay, now remember from chapter 10 that I'm going to write this off to the side, any regular polygon can be inscribed in a circle. Okay, and that circle is called the circumscribed circle. Okay, the polygon is called an inscribed polygon. Okay, now I am going to write the definitions of these so you can copy them, and then I'll go back and explain them. Okay, here are the definitions of each of these. So I want you to pause this video, okay, write down these definitions, and then I'll talk about and explain them, and then we'll label the picture above. Okay, so hopefully you got these jotted down. If not, go ahead and pause it again and jot them down. Okay, but the center of a regular polygon is the center of the circumscribed circle that the regular polygon is inscribed in. Okay, so if I go back up, maybe. Okay, this right here would be the center. Okay, because it is also the center of the circumscribed circle. Okay, we know that this is equidistant to each vertex, meaning that BC and BA would be congruent. Okay, they're just radii of the circle. Okay, the central angle, like we did before, is the angle with the vertex at the center, so that's nothing new. Okay, but of a regular polygon, okay, the two sides are drawn to consecutive vertices, meaning vertices that are neighboring each other. So it wouldn't be like this one and this one. Those aren't consecutive. A and C would be consecutive. So this entire thing here would be a central angle. Okay, the radius is a segment drawn from the center of a regular polygon to its vertex. Okay, so right here, this is pointing to BA. This would be an example of a radius. Okay, what's next? A side length, okay? It would be the length of a side. Okay, so simply put this length right here. Okay, so it'd be a side of a regular polygon. Okay, and then last but not least, this piece right here, up and down, okay, this is the apothem. Okay, now the apothem serves two purposes. Okay, and you'll need to know both of these. One, it is perpendicular to the side, okay, meaning that we cross at a right angle here. That will always be true. And that two, it bisects the side, meaning that AD is congruent to DC. Okay, that will always be true, and that'll come very, very handy as we get going. Okay, so let's look at example 1 here. Okay, first thing we're just going to do is find the central angle of the regular polygon. Okay, so here we have a triangle, so my center's somewhere in here. Okay, and think of a central angle as if we draw from two consecutive vertices. Okay, so this right here would be a central angle. We want to find the measure of that. Okay, but let's think about it. If we draw and create all of these, okay, well, we actually in a triangle would have 1, 2, 3 different central angles. Okay, so 3 central angles. Okay, and because it's a regular polygon, they're all equal. Okay, and think they all kind of create this circle, and so they would all add to 360. Okay, so to find the measure of 1, we just do 360 divided by 3, which would give us 120 degrees. Okay, same thing for a pentagon here, guys. Okay, if this is my center here, okay, here and here, this would be the measure of my central angle. This is what I'm supposed to find. Okay, but if I were to draw all the central angles, okay, a pentagon would have 1, 2, 3, 4, 5 total central angles. Okay, and because it's a regular pentagon, we know each of those angles are congruent. Okay, so essentially to get this, would do 360 divided by 5, and that gives us 72 degrees. Okay, go ahead and pause this, do C and D on your own. C and E, I guess. Okay, and then we'll go over them. Okay, hopefully you've tried these by yourself. Remember, a decagon means we have 10 sides, an octagon means we have 8. Okay, so to find the central angle, would simply do 360 divided by 10. So each central angle of a decagon is 36 degrees. Octagon would do 360 divided by 8, which would be 45 degrees per angle. All right, so before we move on, the area of a regular of an entagon, which is just a polygon with n sides, is 1/2 the product of the apothem and the perimeter. Okay, so therefore our area is 1/2 times the apothem times the perimeter. Okay, so essentially, to find the area of any regular polygon, we have to find the length of our apothem and we have to find the perimeter. Okay, now to do that, we are going to use some trig, so put back on your SOHCAHTOA caps. Okay, so let's look at example 2a. Okay, here we have a square, but we're going to kind of check this area a different way. Okay, we're going to call this a regular quadrilateral. Okay, and therefore we're going to find it using the 1/2 apothem times the perimeter because that's what we're practicing right now. Okay, now notice this right here is given, and this is the apothem. So my apothem is 4. I immediately have that. Okay, now the first thing we want to do on all of these is find the central angle. Okay, that's what we did back in example 1. Okay, remember our central angle would be this whole thing right here. Okay, and we find that by 360 divided by the number of sides. So in this case, it'd be 4, which would be 90 degrees. So this here is a 90-degree angle. So I'm going to put 90 over here. Okay, now that's the whole thing. But remember, when we draw this apothem, okay, we split that 90-degree angle in half. So 90 divided by 2 is 45 degrees. So that means this is 45 degrees and this is 45 degrees. Okay, now I'm going to just draw this triangle here out separately just so I can have more room to draw on it. Okay, so we have a right angle because the apothem creates a right angle. This is 45 degrees and this is my apothem, which I know is 4. Okay, notice I still need my perimeter. Okay, well, I can't find my perimeter, but what I can do is find this little piece right here, and I know that's a small part of the perimeter. Okay, so if I just make this X here, okay, we have a right triangle. I know it's kind of funky looking. So I know an angle, I know a side length, so I'm going to use SOHCAHTOA. So this is my hypotenuse, opposite, and adjacent. Okay, I want my opposite side, I have my adjacent side. So SOHCAHTOA, O and A are together in TOA, so I'm going to use tangent. Okay, so I can say tangent of 45 degrees is equal to, tangent is opposite over adjacent, so x over 4. Okay, and then if I multiply by 4 on both sides, I get 4 times tangent 45 equals x. Okay, and if I put that straight into my calculator, I get x is 4. Okay, that's not my perimeter, but it's a part of my perimeter. Okay, so that 4 is this piece right here. Okay, but go back to our notes before when I said the apothem does 2 things. Okay, it's perpendicular to the side, which means we have a right angle, and it also bisects that side. So because it bisects it, okay, that means this is also 4 as well, meaning that the entire side length is 8. Okay, so to find the perimeter then, guys, I could just do 8 times 4, which is 32. So perimeter's 32. Okay, now to find my area, I would do area is 1/2 times my apothem times my perimeter, which is just 1/2 times, apothem's 4, perimeter's 32, which gives me 64. Okay, so this would be 64 units squared. There is a lot going on, but if you break it into smaller components, it's all doable. Okay, let's look at B now. Okay, first thing we want to do is find the central angle. Okay, so to do that, it's a pentagon, so it'd be 360 divided by 5, and when you do that, you get 72 degrees. So my central angle is 72 degrees. Okay, now they're always going to get you something. In this case, they give us a side. Okay, this is a regular pentagon, so I can find my perimeter as just 20 times every side, which is 5, which gives me 100. Okay, now I want to find the apothem. Okay, the apothem is right here. Okay, I found that this part is 72. Okay, but when I draw my apothem, it cuts it in half. So 72 divided by 2 is 36 degrees. So each of these pieces is 36 and 36. Okay, just like I did over here, I'm going to go ahead and draw this out to make it a little bit easier. Okay, so we know this is 36 degrees. It's half of 72. And guys, this was 20. The whole thing was 20, but when we drew the apothem, it cut it in half. So this is now 10. Okay, and this right here is my apothem. This straight up and down is my apothem. Okay, so once again, I have hypotenuse, opposite, adjacent. And I have my adjacent side that I want to know, my opposite side that I do know. So I'm going to go back to tangent. So tangent of 36 is equal to, well, tangent is opposite over adjacent, so 10 over x. Multiply by x on both sides. Those go away. I get x times tangent 36 equals 10. Okay, then I divide by tangent 36, divide by tangent 36, I get x equals 10 over tan 36. And if you just put that straight into your calculator, you'll get that x is about 13.76. So my apothem's 13.76. Okay, now I have everything I need, because remember, my area is 1/2 times apothem times perimeter. So just 1/2 times 13.76 times 100. Okay, that gives me roughly 688. All right, doing what we've just done, I want you to go ahead and pause this video. Okay, I want you to try to do C and D on your own. Now notice both of these, the apothem is given. Okay, so we can immediately put 4 in for my apothem here and 4.5 in for my apothem here. Okay, so pause this video, work these out, and then unpause it and see if you got it correct. Alright guys, I lied when I drew this out. This is not my apothem. This is my radius. Okay, so you do have to find your apothem. Alright guys, this is what you should have gotten for C and D. Like I said, when I started marking on C, what was given was not the apothem, it was the radius. I apologize, but here's all my work. Okay, look it over. If you screwed something up, find out where you screwed it up and learn from it. It's not a big deal. That's why we have erasers on our pencils. Okay, your homework will be the digital worksheet on Google Classroom. Okay, it is self-checking, meaning that it turns green if it's correct, red if it's not, so you know before you submit it whether or not you have exact answers and 100%. Okay, also look for the rounding to make sure you're rounding correctly. That is also on the schedule.